There we go. All right, so we're going to solve radical equations. And radical equations, when you have the square root in a problem. And your first job is to get the square root by itself. So we need to move the x over so it's just a square root here. So we have the square root of 31 minus 9x equals 5 minus x. I picked this one on purpose because now on this side I have two things. And so when I get rid of the square root, I have to be very careful with the math I use over on this side. All right, so to get rid of the square root, I square, but I have to square everything. And so I square the whole side at one time, not separately. I cannot distribute the squared at all. I have to square the whole side. So the square root and square cancel here. So now we have 31 minus 9x without a square root. And then this gets a box. So we have 5 minus x and 5 minus x.
Can you write that as x minus 5?
You would have to write negative x plus 5 if you're going to rearrange that, because the negative belongs to the x and the 5 is positive. So this would be a 25 minus 10x plus x squared. Okay, and then we're back to just a normal algebra 2 problem where we have to get one side equal to 0. And I'm going to keep the where I have the three things here, I'm going to keep all this right here. And I'm going to move these guys over. So I subtract 31 from the constant. I add 9x to the x part. So these cancel out. I'm good, but not that good. X squared minus x minus 6. So I rearranged it so that x squared was first, but I did the math that was showing there. Okay, so now we need to continue doing the math for this one. And that means we need to box this out. Set it equal to 0. Each one gets set equal to 0. And solve. And just like the other ones, we do need to check our answers. Not everything is going to work, even though we found them doing correct math. So I need to go back to my original, which was the square root of 31 minus 9x equals 5 minus x, and I actually have to go through and make sure they work. So if we plug in 3 for x, on this side we get 2. Over here this is 31 minus 27, which would be a 4, and the square root of 4 is 2. So 3 works. And then we have to check 2. So if I plug in 2, then on this side I get 3. 5 minus 2 is 3. Over here I get 31 minus 18. I'm confused. It's negative 2. Woof, duh. Okay, negative 2. So on this side we get 7, because it'd be 5 minus a negative. So it'd be 5 plus 2. Oh, it's so funny. And then I'm plugging in negative 2, so this would be 31 plus 18, which would be 49. So the square root of 49 is 7. So negative 2 also worked. And a lot of times only one of them works. So this one happens to have both of them work. Most of the time I'd expect to cross one off, but it happens. So that would be solving radical equations. Next question. Why? All right. So here we need to find the domain. This is a rational function, so anytime it says on your paper that you have a rational function you're doing something with, this would be an example of that. When you're finding your domain, remember it's all x values. Domain are the x values. So you're trying to figure out when can you have x values, and actually more specifically you're going to look at when can't you have x values. So because this is a fraction right here, you're looking at when does the bottom equal 0, because remember you can't divide by 0. So you're trying to figure out when does the bottom equal 0, because then that's not in your domain. Right, so we go x plus 2, x plus 1, we box it out. So this is, what else is this? When we do this, this is finding the domain, and it's also vertical asymptotes. Remember how vertical asymptotes is pretty much the same thing as finding domain, except the answer is the opposite. So we solve this and we get x plus 2 equals 0, x plus 1 equals 0. We solve it, we get x equals negative 2, x equals negative 1. Now, if we were finding vertical asymptotes, that would be my answer. But domain, remember vertical asymptotes, you don't have those. Those are those dotted lines where you don't have a point. So domain is going to be all but x equals negative 2 and negative 1. So basically you're saying the domain is everything but those two values.
You see, you have to do the one on bottom.
Yes, it's the one on bottom, because the bottom is where you can't divide by 0.
Do you have a top?
On the top, when do we set the top equal to 0? Do you remember?
For x? For the range? For the thingamajigger?
For the zeros. Remember, if you're trying to find the zeros or the x-intercepts, y equals 0. And so if the top equals 0, then the whole thing would equal 0. So we set the top equal to 0, and those would give us the zeros of the function.
Wait, yeah.
I don't know, is it on your, do you have to graph rational?
Yeah.
Yep. You gotta find the x-intercepts.
I have a question. So then to do the horizontal, since the x equals negative 2 and the x equals negative 1, that would be your vertical, right?
That's your vertical
But
asymptotes.
then what is the horizontal?
Horizontal are those 3 rules. Remember, top heavy, bottom heavy, and the same. So for this one, it is the same, so it's 1 divided by 1. So the horizontal asymptote is y equals 1.
Do we have to know how to do
You have to graph rational function. What part is that on? Part 3. So yes, you have to do that. Remember, for rational functions, you have to graph the horizontal asymptotes, the vertical asymptotes, the zeros, the y-intercepts.
4.
Mm-hmm.
Do you even and you can like equal to 0 and you can move the 4 over and square root it, so it'd be like 2.
Plus or minus 2.
Equals 2.
Plus or minus 2.
Plus or minus 2. Do you even have to do anything then? Or like what was that? That would just be the
So
asymptote
You
would
talk
equal-
so fast.
I didn't think it was it?
I thought you was talking so fast I could not keep up.
Okay, so anyway, so the top is set equal to 0 if you're trying to find the x-intercepts. And so we're going to take that and set it equal to 0. So we have x squared minus 1 equals 0. Add 1 to the other side. So we get x squared equals 1, square root both sides, or you could have boxed it out up at the top. And we get x equals, I'm running out of room here, x equals plus or minus the square root of 1 is 1.
So is that the
Those are the zeros or the x-intercepts. So what we would say is 1, 0 and negative 1, 0 are our answers for the x-intercepts. To find your x-intercepts. So if you remember when you're graphing a rational, you have your x-intercept. Whoa, wrong button. Sorry, guys. Okay. You have to find your x-intercepts, you find your y-intercepts. Remember, there's the notes on the side. Vertical asymptote, horizontal asymptote, and there's even the slant asymptote. Okay, so for our x-intercepts, we plugged in 0 for y. That's where we had, right, we plugged in 0 for the y right here. Okay, we plugged in 0 for y, and we got our x-intercepts. So then that is 1, 0 and negative 1, 0. So Micah, that was your question right there. Okay, for our y-intercepts, we plug in 0 for x. So we go back to our equation here, and we're going to plug in 0 here, 0 here, and here. So there's all I'm left with is the -1 on top and the 2 on bottom. Yep. So then that means I get 0 and -1/2 for my y-intercept. Our vertical asymptote, we found when we set the bottom equal to 0, and the whole point we did this problem was finding the domain, but we're using it now to figure out graphing. So for our vertical asymptote, it's going to be these two. We've got two vertical asymptotes. So x equals -2 and x equals -1. And if you remember on your test, if you didn't write x equals -2, you just wrote -2, you got some points taken off, because it's an equation of a line, and that needs the x equals on it. The horizontal asymptote we already found also, which was right here, because we followed the rules, the 3 rules, where you have the same exponent, so it's a 2 and a 2, so we took the numbers in front and divided them. So then we have y equals 1 as our horizontal asymptote, and there is no slant asymptote, because you have a slant asymptote when the top exponent is 1 bigger than the bottom exponent. You can't have both of them, because then it would be top heavy, and so then there is no horizontal. Okay, so we don't have a slant asymptote. No horizontal asymptote. Huh? You can look one up where it's 1 bigger. And don't forget, I have those videos in Google Classroom, so I'm pretty sure I did a slant asymptote one in there. Now, for the rest of this, the graphing of this, oh boy. So, you're going to make a table. Going to make a table. And before I make a table, I'm going to draw what I've got so far. So like I've got a vertical asymptote at -2 and at -1, which kind of sucks because that means I'm going to have to plug in points in between -1 and -2. I'm going to have to get some decimal stuff going here. So we're back to recording. All right. This one, we're going to stop here because I totally messed up making up this problem. Because you should not have this and this overlap. You can't have a vertical asymptote and a point on that vertical asymptote. And that's not normal. I just did a really bad job making up this problem. So we're not even going to continue because that just totally wrecked stuff we were doing. So, yeah, we're going to move on to another problem. Next question. Yeah. Yes. Say that louder.
Solving logarithms.
Oh, solving logarithms. Well, that's exciting. All right, we're solving logarithms. And so the first thing is you want to get the log by itself. Can I just point out this 3x is inside the logarithm, so you can't get rid of that. Okay, so it's not like you can divide by 3. That's stuck inside the logarithm. But the 2, however, we can get rid of, and it's being multiplied, so we'll divide by 2. So we have log base 5 of 3x equals 4 divided by 2 is 2. And now we need to get rid of the log. And so to get rid of the log, we exponentiate. So I'm going to take 5 and raise it to, I'm going to make this an exponent, is what exponentiate means. And then we also have to make this an exponent. So we've made them both exponents of the same base 5, and I picked 5 because the base of logarithm is 5. And now we have our Tetris effect, because whenever your base of your exponent and base of logarithm are the same, they cancel. And so what we get is what's inside, which is 3x. And 5 squared is 25. And then it's just a simple problem to solve, divide by 3. So x equals 25 over 3. You always want to double check that if you were to plug that in, that it wouldn't make that negative.
Zero.
It can be 0, oh, no, can you plug in 0? No, you cannot plug in 0, so it can't be 0 or negative.
Good question.
When you plug it in.
Mm-hmm. All right, and then we have the next problem, which is log base 10 of 5x plus log base 10 of x minus 1 equals 2. Okay, so this is a little bit more difficult because we have more than one log, and so we have to deal with that.
Are we solving it? Or condense? That's it?
So, if you remember back to our log properties, okay, pause for a second. One of the things that people are tempted to do is they're tempted to go right to exponentiate and say 10 to this power, 10 to this power, 10 to that power. You can't do that because you can only do it once on each side.
Oh,
So we did it too many times. So you have to get it so that you're only going to do 1 10. Right, so we're going to use our condensing rules to help us with this. So our condensing rule says if we have a plus,
you multiply.
we multiply what's inside the logarithms. So now we have log base 10 of 5x times x minus 1 equals 2.
Now you can exponentiate.
Right, now I can exponentiate on both sides. So now it's 10. I chose 10 because of that. Is log base 10 of 5x times x minus 1 equals 10 to the 2. Okay, then these, we got Tetris effect. So 5x times x minus 1 equals 10 squared is 100. And now it's back to algebra 2 stuff. So we multiply through by 5x. So we got 5x squared minus 5x. I'm going to move the 100 over right now anyway, because I know I need to get it equal to 0. And then we're going to box it out. Red pen. All right. Pizza. Was there pizza today even? Okay.
We have pizza.
Oh, you had, well, then that's why you thought.
Yeah.
Okay. Before I box it out, you can box it out this way, but I'm going to take out a 5 because it's going to make my math a lot easier if I factor out a 5, which means I'm dividing by it. So then, if I do that, I can box out what's left in the bubble. And then I take the bubbles, set them equal to 0. If 5 had an x there, I would also take that and set it equal to 0, but at this point 5 can't equal 0, so I'm not going to do that. So we've got x minus 5 and x plus 4, they both equal 0. Solve them, x equals 5, x equals negative 4. And we need to check that they both don't make the inside of the logarithm negative or 0. And so if you remember, the original was log base 10 of 5x plus log base 10 of x minus 1 equals 2. Okay, so if I take 5 and plug it in, I get 25, and 5 minus 1 gives me 4. Neither of those are negative or 0, so x equals 5 works. If I take negative 4 and plug it in, I get negative 20, so that already means it doesn't work. But over here I get a negative 5 too, so it doesn't work twice over. So negative 4 can be crossed off. Only 5 is a solution. Other questions? That covered everything, really. We got more time. More questions,
How
please.
about, can you do substitution?
What a complex fraction.
All right, so I heard expanding, substitution, and what is a complex fraction? What does it say about complex fractions?
That's the ones which
Oh yeah, that's like, where did we do that?
Oh,
That was on day one.
I wonder if that's really what that means.
What?
Okay, so complex fractions is like what I showed you yesterday, where you were adding and you had like complex 3 plus I on the bottom and 3 minus I on the other one. So that's what complex fractions is. All right. Expanding. If you're talking about logarithms, so if I had log base 2 of 3x to the 4th and the square root of y over z cubed. Okay, expanding is where you write them. They each get their own logarithm. So it's going to be log base 2 of 3. And because these are all multiplying, I'm going to add. So plus log base 2 of x to the 4th plus log base 2 of the square root of y. And then z cubed is being divided, so we'll subtract that one. And then the second step is to get the exponents out in front. So it's still log base 2 of 3 plus this 4 needs to go out in front. Log base 2 of x plus this is technically y to the 1/2, so it's 1/2 log base 2 of y, and then minus, put the 3 in front, log base 2 of z. So that would be logarithm expanding. The other expanding, that if you see that on there, water bottle, I swear. Okay. The other expanding is 2x minus 3 to the 4th power would be the other expanding. And so then that is this last test, which you guys did really well on. So, you know, it'd be 4 choose 0. It'd be 2x to the 4th power, negative 3 to the 0, plus 4 choose 1. 2x to the 3rd, negative 3 to the 1, plus, and then so on. That would be the other expanding. Do you want me to keep going on that, or?
No, you get.
No, that's pretty good.
Okay. And just make sure when you do something like this, that 4 goes down the 2 also, so it'd be 16x to the 4th. Don't forget that part, please. And then I believe substitution was the other one?
Yeah, that you just have to like make the x.
There's all kinds of stuff still missing. I'm not testing on every single little thing we did in the semester. So I just picked things that I'm going to test you on, and that's one of them.
Just the things we struggled with.
No, not necessarily. So substitution is, I'm just going to pick a quick problem here. So it might, I don't know, it's not the most difficult problem in the world, but so if we were going to do substitution on this one's set up for elimination, but if we were going to do substitution on this one, what you're going to do is first figure out what variable you're going to solve for. So pick a clean variable. Okay, and so let's say that's the one I'm going to do. I need to get that x by itself, so I'm going to get rid of the 2y. So now x equals 4 minus 2y. And I'm going to take that and plug it in for x right there. So then I have 4 minus 2y, and then copy down the rest of the equation. And then it's just a matter of solving. Okay, now, this is my last time seeing you before we come back on the 3rd. The 3rd is going to be a review day, and then we test the 4th and the 5th, okay? And then you're done with college algebra.
You have a final for Chase?
Yep,
It's just one whole day or one test.
one test, but it's 2 days worth.
Oh, 2 days. Okay.
Yep.
We can't, like, what are we gonna do Monday and Tuesday and Wednesday of the next week?
We're going to start trigonometry.
No, we're gonna chill.
No, it's serious. I'm still recording too. Here's what I want to tell you. You need to work on this while over break. Okay? If you're not going to work on this, don't count on doing well, and don't count on me having pity and a lot of green pencil. Yep, serious,
Oh, that's not
serious.
funny.
The green pencil will be there, but it's not gonna be, you know, the way you get through this. You need to do some work on your own. I plan on coming in some during break. So I think what I'm gonna do you guys get notices in Google Classroom? Like if I,
No.
do you,
And when you post
Send
something,
emails.
when you post something, I get an email.
I don't check my email.
See, I don't open my phone.
well, this is how I'm going to do it though.
You just text me.
No, you can have one of these guys text you, but I'm not texting you. So I am going to, I'll put it in Google Classroom. If I'm gonna come in, whatever date I decide to come in, I will put it in Google Classroom, let you know what hours I will be here. And if you guys wanna come in. If you guys talk to each other and you're like, hey, what are you guys all doing this day? Let's study. Let's see a strum. You laugh, I'm serious, okay? I'm serious. But if you guys are like, let's study, and which is a really good idea and not nerdy because you need to do well.
I didn't say later night.
Anyway, if you do that and you want me to be involved in that, is all you have to do is shoot me an email, and as long as I don't already have something going on, I'll be here, okay? Yeah.
We should do it January 2nd,
I'll be gone that day.
because there's already gonna be a board meeting, so a lot of people already have to be here that day,
Yeah.
so like. that'd be
If we did it January 2nd, we would have to do it in the morning,
Oh,
Just kidding.
just.
because I believe my family is going somewhere that afternoon.
Oh,
She won't be at the game.
I said it.
I'm sure we'll think.
Okay, but doesn't mean you guys can't get together and study, okay? All right,